big crowd in a way. I've worked for the state for 22 years. I started out at the radio shop at Calvin Ramsden as a technician for the highway patrol. And for 11 years, my primary responsibility was maintaining all of the communication systems in the northern counties of the state. So all of these mountain peaks around here with towers on, those are all mine. Well, were mine. And I increasingly, as the technology began to become more digital, this is back in the early 90s, as technology started to become less analog, more digital, I became very interested in networking and went back to school, got a bachelor's degree in information technology and in networking and in software development. And actually I spent a couple of years even with ITS as a software developer and developed some programs that were being used by our department or our group for billing and accountability and whatnot. So I have a little bit of background on the programming side. I'm not a full-time professional programmer. I do a little moonlighting on the side. I do some mobile app development, iOS and Android. And so really my focus today is going to be on securing web application development. This is an interesting topic, and it's one that everyone should be really focused on because the threat landscape is so big, and we'll go into that. But before we do, I have a message, a special announcement from Anonymous. Anyone seen this before? I hope the sound's loud enough. Types and motivations. I suspect that everyone in here that is a programmer or that is involved with technology is probably a hacker of sorts. It didn't used to have a negative connotation. You know, back in the 80s, a hacker was somebody that just was really deep into technology, kind of a nerd. Now, we think of a hacker as a criminal, but anyone that is trying to, that's looking at technology, that's trying to expand or investigate its capabilities is really a hacker, but they don't hack for the same reasons. They're doing it out of curiosity. And then, of course, there's the script kiddie. These are, for the most part, these are kids. High school, college, junior high. And their motivation is power and to be elite. It's all about being elite with these guys. And then there's the hacktivist. Anyone gather with the Occupy Wall Street crowd last summer? Occupy Wall Street was a political movement, and there are lots of political movements, some good, some a little scary, and it doesn't really matter whether the motive of that political movement is good or not. There's always going to be some folks out on the fringe of these movements, whether it's, you know, protecting the earth or you know, we don't like this political party or that or whatever. There's always going to be some folks on the fringe that are going to get enticed into some cyber criminal activity. The professional hacker. Anyone in here know someone that makes their living hacking? Yeah, besides me. So there are a significant number of people that make their living as hackers. And who are they? They're people just like you and me that have been laid off, can't find a job. They've got the technical skills. After 2 or 3 months of being on workman's comp, they get discouraged and they start looking for opportunities, and the opportunities are there, and they get recruited into something. Professional hackers are scary because they're not like the script kiddies. They know what they're doing, and they know indignation. And state-sponsored cyber attacks. Anyone follow the national trends when it comes to hacker activity? Well, if you do, you'll notice that in the last 2 years, cyber espionage from state-sponsored countries and groups is now the second largest category of cyber crime, cyber activity. So it's becoming really big. Now, state-sponsored cyber activity, they're not trying to steal your credit card number, but they do want to, so that they can resell it, but they do want to get all the information they can get. It's very important. They're looking for org charts. They're looking for, who goes to church where, who's involved in what, how it's all laid out. And, we can speculate on why that information is so important, but apparently it is. So just really quick, before we go into the core of my presentation, let's just cover or go through this strategy, because this is really the nuts and bolts of hacking. Number one, reconnaissance. A good hacker doesn't just fire up a tool, download Metasploit, and just start firing off things out into the wild. In fact, that's how you can really tell. We see on the state network, we monitor 24 hours a day, 7 days a week. We monitor all of the data that's coming in, going out. And we see a lot of noise. And the people that are really scary are not making a lot of that noise. Why? Because they've done their homework. They've done their reconnaissance. They know everything about an organization before they ever pull the trigger. They know who works there. They know what the network ranges are. And so their attacks are very surgical. The kids that are just trying to get attention, they're very noisy, very easy to spot. So reconnaissance is really where the professional hacker is probably most expert. And then of course scanning. Once you've determined that you have a target, you want to know what lives next to what. So if I can identify a website on an IP address, my very next question as a hacker is, well, I know that's sitting on a server on a network segment. Who are its neighbors? What else is on that segment? Is there a database on that segment? Are there other websites? Are there other more easily compromised assets that are neighbors to that asset? So that's what scanning is all about. And once you've port scanned and you've kind of mapped that out, then you begin to enumerate each of those assets. So you'll start sending, you'll develop scripts that are going to try and talk to that using NetBIOS if it's available, SMB. If Tomcat is is activated, if that's an Apache service, server, and Tomcat's there, you'll start trying to enumerate services, users, directory structure. Once you've determined what the world looks like and who the players are, you're going to attempt to gain access. Now, it used to be that primarily people would try to gain access using brute force methodologies. The brute force methodology is really slow. Unless somebody's password is part of all or part of a word that's found in a dictionary, and there are rainbow tables that are available on the internet that have billions of words from the dictionary and combinations of words that have been hashed. And so if you can get somebody's password or even part of a password, and you run it through those rainbow tables, the hash, you can usually get that password within just a few seconds. But if it's a complex password, that's something that's random and complex, and it's not a word that's going to be found in the dictionary, it takes a lot longer, and brute forcing, it's not even worth it at that point. But that's not how the hackers gain access now. The predominant method that is used now is phishing. So I've done my homework, I've scanned the network, I've selected my target, I've enumerated, I know that you work in this organization, I know your title, I even know your email address, I know your login name, now all I need is your password. So instead of trying to brute force my way into an asset that you would have access to, I'm going to send you an email, and I'm going to phish you for those credentials. The reason that phishing is so pervasive is that it's effective. It's very effective. And we've got to be ever on our guard for it. Once I get in, if you don't have admin or root on that box, the next thing I want to do is try to elevate my privileges, because it's all about owning the box. And then once I've done that, I'm going to go in and clean up whatever logs I have access to minimize the opportunity for someone to find me. And I'm going to create a back door so that I can come back later, and so that I can sell that access. So in a nutshell, port scan and banner grab the target, find out all the information you can, figure out what exploit code you need, go out and download it, and then own the box. That's, in a nutshell, that's what hacking is really all about. It's all about owning the box. And you want to own it because then you can sell the data that exists there and the access, and you can sell the access 100 times, and the data. Or you can deface, dox, deny access, defraud, extort, execute additional exploits intended to create chaos and mayhem, and it's just whatever your motive is. Some hackers do it for the lulz, and some do it for power, but most do it for money. Without any question, the greatest number of people that are involved in cyber criminal activity are doing it for money. You know, we keep hearing about Anonymous and how big and out of control it is, but really, if you take all of the activity from groups like Anonymous, it's only about 10% of all of the cyber activity that we see. So let's talk about why web applications are such a juicy target. One, they're ubiquitous. Web applications are almost everywhere today and continue to spread rapidly across public and private networks. When did the internet or the current iteration of the internet really become popularized? Anyone remember back in about 94, 95? Anyone here back when the state all of a sudden got the internet? It was so amazing and cool. I remember when the state first got the internet, I was blown away with how cool it was, and it didn't hardly do anything. All the pages were static, and there weren't that many. In fact, when the internet first came out, you had to go down to Barnes & Noble and buy a URL yellow book. You had to look up the URL, the site that you wanted to get the IP address to load it into your browser, because DNS hadn't really been designed yet to resolve all of those URLs. Anyone besides myself and Dave and Bob remember the good old days? Well, now, the World Wide Web touches everything. I mean, it touches everything. It touches your phone. It touches all of your portable devices. In fact, now, I don't know if there's any cars out in this parking lot, but there are cars now that are connected into the internet. With IPv6, you'll see that almost everything that you take for granted today is going to, in one way or another, touch the internet. So it continues to be ubiquitous. And the other thing that makes web applications so juicy is that there's relatively simple techniques. I mean, stop and think about it. HTML is incredibly simple. Compared to the technologies that we work with today, HTML, HTTP, very simple. And yet, that's still at the base of that framework and still gives a lot of opportunities. So this makes manipulating application input fairly trivial. It's nothing to intercept and manipulate a get or a post, coming from or to your browser. And there are thousands of open source tools and scripts available to help facilitate an attack against a web app. And compared to the knowledge required to attack more complex applications or operating systems, buffer overflows, for an example, that's not that easy. Man-in-the-middle attacks, not really that easy. But attacking web apps with a tool that you downloaded off of the internet. Anyone heard of Havage? Havage is a SQL injection tool that you can download off the internet, and you put a URL or a web or an IP address in, and that thing will just tear a database apart if it's not well protected. You don't even have to know how it works. You just run it, and all of a sudden you've got 75 pages of data. Anonymity is one of the biggest reasons that cybercrime and the hacker movement continue to flourish. And the reason is that there are so many ways to hide your identity, to remain anonymous. Anyone familiar with a proxy chain or a proxy? How about an anomalizer like DuckDuckGo? If you do a search on Google, Google tracks your search and all kinds of stuff about you. But there are sites like DuckDuckGo that you can go to. It's a search engine that doesn't track what you're doing. And then there are actual proxy, web-based proxies like, and forgive me for the name, I didn't make it, but one of the most common is hidemyass.com. You can go to that site and you can sign up for a service, and then you can determine what country you want your traffic to proxy through. And you can even set up a proxy chain of 3 to 6 proxies in the chain. The FBI, if the proxy chain goes over to Russia or China, and there's more than 3 proxies in the chain, they're not coming after you because they just can't find you at that point. So it's easy to remain anonymous and to hide your activity. So you can literally be right next door to your target, and everything that they know about you is that you're coming out of Romania. But not really. It just looks that way. And then, of course, the other thing that makes it so juicy is firewall evasion and bypass. It's completely pointless to set up a website if you're going to block port 80 and 443 at your firewall. So if you set up a website on a server, obviously you're going to open those ports because a website doesn't make any sense if you don't, and the hacker knows that. So a hacker will scan your entire range just looking for assets that have port 80 open. And then once they get to port 80, then they have opportunities to spoof other protocols across that port because it's going to be open. Custom code. This is another thing that makes web applications so challenging from a security perspective. With the proliferation of easily accessible web development platforms, most web applications are assembled by developers who have little prior experience. I know a couple of you I've worked with for several years, and I know that you have years of experience coding in this environment. But how many people, even within the state of Utah, state government, how many people that are directly working on web application development have more than a year or 2 or 3 experience? There are a lot of folks. You know, the barrier to entry into this field is pretty low. Now, if you're going to be a programmer, if you're programming a very complex program, doesn't have anything to do with web application, it's going to be harder to get into that because you're going to have to have a lot more experience, a lot more training. But web development, a person can take a couple of CIW courses and pick up a CIW site development certification in about a month and a half, and now they're ready. They're programmers. And we see a lot of folks that really just don't have a lot of depth. So again, back to HTTP. One of the things that HTTP doesn't do as a protocol is it doesn't implement sessions to separate unique users. If you've got a website and you've got a couple hundred people coming into that website, HTTP doesn't segment those users apart from each other. That makes it very delicious to an attacker. And basic authentication and authorization plumbing for HTTP, like so many other technologies, was bolted on long after the fact. HTTP, when it was originally created, was a really simple and basic technology, and it really hasn't changed a lot. It's gone through a couple of iterative upgrades, but it's still really a very basic technology. And almost everything that works with HTTP, as something that has kind of been kludged into it after the fact. And because that's the way it is, many developers code their own, and unfortunately, a lot of times they just, when it comes to security, they just get it wrong. And so we end up with a lot of problems. So, let's see, I guess we had that. One of the other things that impacts or makes web development, web application security problematic is this constant change. It's a continual change of personnel. It's a continual change of the technologies. Everything that we're doing today, 6-8 months from now, is going to be so yesterday. And I mean, look at the web applications that you were developing, say, 3-5 years ago, and look at them today. The change in all of this is just so rapid that it's hard to maintain continuity. And security really likes continuity. Security likes to define policies, processes, and standards, and then have those elements be enforceable going forward. And web app development makes it really challenging. Anyone do anything with Joomla or any other CMS, WordPress? A whole different ballgame than some of the static or even dynamic sites that you were creating 4 or 5 years ago. And the big driver for cyber criminal activity is money. Anyone have any idea what the U.S. Department of Justice estimates cybercrime to be worth in 2012 as part of the economy? Over $1 trillion worldwide. Over $1 trillion in this black market economy that we call cybercrime. And that's a huge driver, because frankly, if you're working as a hacker, you pay no taxes, because you're not reporting it, neither is anybody else. And it's just not that hard to get what you need to get and buy and sell and trade and money. I mean, there are people that make a really good living quietly in the basement of their house as cyber criminals. So this is kind of an interesting, this second bullet point. Recent statistics indicate that the motivation for web hacking has moved from fame to fortune. 3, 4, 5 years ago, the primary motive was fame. And one of the things that people would do, professional hackers and the script kiddies alike, is they would go out and deface a site, but they would do it so inconspicuously that no one could actually tell. So they'd go out, they'd take over a website, and they'd go onto a web page, and they'd maybe change the font of one letter in a paragraph. And then they'd use that as evidence among their peers to say, I was in there and I can prove it. Because if you go out there, you'll see that the letter P in this paragraph is a different font than the rest, everything else in there. That was me. I did that. I own that box. And it was a way of both keeping score in those organizations as who was really the scariest hacker, and it was also a way to market your goods. I mean, if I wanted to sell you access to utah.gov, if I just walk up to you and say, hey, I've got a backdoor on utah.gov, $100, it's yours, you're going to say, really? Show me this backdoor. So I have to be able to give you something, and this isn't a conversation we're going to have face-to-face. This is something we're going to do in Second Life or in one of these other environments, online environments, or possibly even in a chat room. So I have to have something to give you to show you that I own the box, and defacement used to be really big. So we routinely scan all of the websites in the utah.gov domain, looking for these little anomalies that could represent that type of activity. So, weak points of web applications. Some of these speak directly to Java, and some of them don't, but Java is just part of the mix. Java is so pervasive in this space that every one of these weak points really applies to Java, but not necessarily Java coding itself. So the web platform software vulnerabilities, again, we've talked about HTTP as a protocol and how insecure it is, but there are several of these others. I mean, PHP, .NET. Most of these frameworks have not only vulnerabilities, but published vulnerabilities. So if I know what version of Apache you're running, all I have to do is go out and look on the list and say, oh, well, that version of Apache is subject to this list of exploits. So web application attacks against authentication, authorization, site structure, input validation, application logic, and management. This is actually, this category, and what it has just put on this slide is the number one. This is the big, this is the single biggest, most attacked target for the last couple of years. Database, again, if you've got a website and you've got port 80 or 443 open, and that front end on that web application is talking to a database on the back end, and you don't have good input validation between those, that database is exposed to the internet, and no matter what else you do on your network. You can lock everything else down solid, but if you've opened that one up, port 80 to the internet, that database is exposed or potentially exposed. And then the client itself. Active content execution, client software vulnerability exploitation, cross-site scripting, and fraud like phishing. So that really, most of these attacks where you get redirected off to a malicious website and it pulls down some JavaScript and infects your browser, that's what this is talking about. Most of these browsers really have a lot of security issues, and there's a lot of opportunity because these browsers will support so many different plugins and extensions. There's all kinds of opportunity for someone to craft malicious code into a plugin or an extension, or even just redirecting that browser off where it now gets a hold of some of this malicious code and starts to execute it. The transport layer itself, eavesdropping on a client server communications and SSL redirection. This actually isn't quite as easy as it sounds like it might be. Eavesdropping here really requires that you put something out there that is going to collect information and send it back to you, or you've got to physically go and put a tap or Wireshark or something. But it's still effective. Anyone familiar with this latest 2 million, Google, Yahoo, Twitter exploit where a couple of million people's credentials were shipped over to the Netherlands? That was kind of a form of eavesdropping of certain specific types of activity, and then sending those credentials off to the Netherlands. So availability, this is often overlooked because back in the good old days when a web server was sitting on a 386DX with 4 or maybe a 2 gig of RAM and a 10 base T Ethernet card, it wasn't really that hard to perform a denial of service attack against that asset. But now with load balancing and we just don't hear as much about denial of service today as it used to be more common. But it's still out there and it's still big. And if an attacker can identify an asset that isn't really protected against that type of an attack, they'll still hit it for any one of those motives that we talked about earlier. Anyone familiar with lowWASP? lowWASP is an organization, it's a nonprofit, really a collaboration between a lot of academic institutions and other government entities and such. And they have business interests, and they've formed this kind of an open source community that is singularly focused on web development and the security around web development. And they're probably, in the US, they probably have the most credibility of any organization in this domain. So every year they come out with the top 10. They say, of all of the attacks that we've seen in the last year, here's our top 10. And you'll see that number 1 is injection. 2, 3, 4, 5, we'll go through these. If you haven't gone out to lowasp.org, you should. There's some really good good data, good tools that, they have quite a tool collection there that you can download and test your own work. So injection, we hear about SQL injection, but there's all kinds of injection opportunities. We had one just a month ago here in the state where someone had a form, and they had a form field that wasn't, they didn't have good input validation on that form field. And so somebody, they didn't SQL inject that because they weren't trying to talk to a database. They actually uploaded the entire JavaScript, malicious JavaScript code in that form field and took over that web server using that. So injection it's big. Broken authentication and session management. It's not really hard to take over authentication when it's really basic, like with Tomcat. The authentication in Tomcat is really basic, and so we just session management, a little bit harder to do, but it's not that tough to break most of the authentication that is out there. Crosssite scripting, another This is another one that's really big, and everyone know what cross-site scripting is, how it differs from SQL injection. So SQL injection, I'm trying to talk to a database through your front end by using any input point where I can put a SQL statement and talk directly to that back-end database. Cross-site scripting it still involves injection, but I'm not trying to talk to a database. I'm trying to talk to that hosted web site, that web server, or the application itself. And if I can inject code into a website, I can actually change your JavaScript to my JavaScript, replace some JavaScript module with my own. That creates a redirect on that website so that every subsequent user that goes to that website is now redirected off to my malicious website that looks just like yours and asks for your credentials. So insecure direct object reference. A direct object reference occurs when a developer exposes a reference to an internal implementation object, such as a file, directory, or database key. It surprises me how often we perform a vulnerability scan on a website, and we come up with the entire directory, and when we get looking in the directory, we find a folder, and in the folder are the SSH private and public keys to that or something else, or sometimes even a document with the administrative password to that or a database that talks to or something. So we've got to do a better job of locking these objects down and not providing a trail to all of those things that we don't want exposed on a public website. Security misconfiguration, again, this is largely, this happens out of a lack of understanding and or sometimes it's just inexperience. If you've never set this up before, maybe you're handed an environment, this is your first go around, and you just really don't have the experience to set it up for security. And because everything changes so fast, that happens frequently. And then sensitive data exposure. Many web applications do not properly protect sensitive data, such as credit cards, tax IDs, et cetera, et cetera. I guess you probably heard on the news that JP Morgan suffered a breach earlier this year, and they just now released information about it. Well, that's going to impact over 50,000 credit cards in the state of Utah. And that's just one of many states. And they actually thought that they had this stuff pretty well protected, just like us. I mean, we think we're doing a pretty good job until somebody shows us that we missed something. But it's not just Social Security and credit cards. I mean, almost all data is potentially sensitive because it's a piece of a jigsaw puzzle. If I know your name and I know your home address, I can get all kinds of information about you. If I know your cell phone number, I can get even more information about you. If I know your driver's license number, I can get even more. It's like building a jigsaw puzzle. And so sometimes we look at information and data and we go, it's not important, nobody cares about that. But it's all important within the context of the jigsaw puzzle. So missing function level access control. Most web applications verify function level access rights before making that functionality visible in the UI. Certainly, we should be ensuring that those processes are in place. But sometimes what we're not doing is we're not validating those processes across everyone that could potentially have access to that process. So we might validate the process in a certain scenario, but then we're kind of leaving it wide open in a different scenario. And when it comes to access control, that's particularly important because, you know, back to that enumeration. If I can get even a foothold into a system where I can enumerate who the users are, what the accounts are, I'm off to the races. And then Crosssite request forgery. Anyone familiar with this term? So it's an attack that forces a logged-on victim's browser to send a forged HTTP request, including the victim's session cookie and any other automatically included authentication information to a vulnerable web application. This is almost always done with the cookie. So if you are developing a web application that's storing credentials in a cookie, those session credentials, you need to consider there may be some safer ways to do that. And using components with known vulnerabilities. How many of you use third-party plugins or extensions on any of your web applications? And how much do you know about those extensions and plugins? None of us know a lot about them because most of them are developed by somebody that, you know, just working alone or in a small group. I mean, a lot of these extensions and plugins that we're using either came from the open source community or some small, completely unverified little shop. Not a lot of these are coming from big established firms that have a, you know, $3 billion business and a reputation. We need to do a little homework when we're using these and make sure that we're not plugging malicious code into our applications, or it doesn't even have to be malicious, it can just have zero security. And then unvalidated redirects and forwards. Web applications frequently redirect and forward users to other pages and websites. I mean, this is normal. And it uses untrusted data to determine the destination pages. Well, this is typically how it works, but without proper validation, attackers can redirect victims to phishing or malware sites. That's what cross-site scripting is really all about. It's an attack that exploits the fact that we do frequently redirect and forward users to other pages and websites, even within our own application. And if we're doing that without proper validation, an attacker can exploit that and use that. So here's another report, the White Hat Website Security Statistics Report. This is for last year, 2012, and according to their research, 86% of all websites had at least one serious vulnerability. And it's worse than that for government because in this report, 100% of all of the government websites and web applications that this company did research on had a serious vulnerability. Here within the state, our vulnerability scanning that we do in my group, it's about 60%. About 60% of the websites and web applications in the Utah.gov domain have a serious, a critical or high priority vulnerability. And this is the other thing. Serious vulnerabilities were resolved in an average of 193 days from the first notification. It just takes a long time to fix these, and the reason is that the factors inhibiting organizations from remediating vulnerabilities it's very common. You've got an application out there and it's an orphaned application. Any of you familiar with an application that somebody developed and now they're gone and nobody really owns that? You know, maybe you and somebody else kind of take turns keeping it going, but you don't really own it. You don't even necessarily know what the code is. You haven't even actually looked at it, or if you have, maybe you don't really understand how your predecessor put it together, but your job is just to keep the train moving. And then, of course, lack of budget to fix the issues. I mean, that's huge with us. Every time we run a vulnerability assessment and we find a website that's got some issues, it's more often than not, it's related to some version that needs a patch level upgrade, and we can't do the upgrade because it'll break the application, and so who's going to pay for all that? And the business comes back and says, I don't have any money to pay for that. So we just keep running.
Can you give some specific example?
Yeah, so I don't want to target any particular agency, but it's very common. We'll have a website running on Apache, and maybe it's you know, a version of Apache that's a couple of years old that has a lot of vulnerabilities, and we go in and we say you need to upgrade, you need to do some patch level updates on that server with Apache and with Java that's running on there, but the developer comes back and says, well, no, we can't update the Java because it'll break the application, because my application needs this version of Java to run. If you all of a sudden you're running, you know, you upgrade to Java 7 and my application is written for Java 6, it might break some of my functionality. So in order for you to update or patch upgrade Java on that server, I've got to go in and rewrite my application to work with Java 7. But who's going to pay for that? You know, it's not going to be DTS. So then DTS has to go back to the business and say, this application that you have needs some work, and it's going to cost this much money to do all of this work, and the business says, we don't have any money.
So basically what you say is not resolved. Never will be resolved.
Yeah, so a lot of these issues just don't get resolved. So what we do is we try and put other controls in to mitigate that, because it's less expensive than whatever it's going to cost to rebuild the application and upgrade, you know, the server. And
we had a situation, was it a couple months ago, we had an agency using Java 6 and using insecure ciphers for some financial transactions. We had to upgrade to Java 7. It was hard.
yeah,
Not that the upgrade itself was hard, but again, it was one of those orphan codes that had been written some time ago using old ciphers.
yeah, and the person that wrote that probably isn't even
Gone.
still here.
Yeah.
So nobody that's currently working or that kind of has that orphan, they don't even necessarily know how that was written in the first place. So they got to completely rebuild something new.
And that's what we did.
It's going to take a lot of time
Yeah.
to do that, and somebody has to pay that cost.
It's the case maybe worse because test environment has one version, development environment has another version, and the production is completely different version.
Yeah, that's a problem.
So
And that's another problem, is that, you know, people tend to spend the money that's required to, you know, for production, but the development environment is often, you know, we just don't spend enough money to make them compatible.
plus it's not under control of the agencies. DTS controller, what's the good?
That's right, yeah. It's a problem. I mean, there are some really good, legitimate reasons why these issues are out there and why it's so hard to secure this. But despite that, all of that, Java itself is a pretty secure programming environment. In fact, there are some unique security features in Java that you don't find in C or even C++, some of the more traditional. Let's point a couple of these out because I know that you're probably very familiar with this, but like the language is type safe and the runtime provides automatic memory management, bounds checking on arrays. So that means that if you code something in C++ and you don't have good bounds checking on your code, on your arrays and your variables, it's not that difficult to create a buffer overflow exploit against that code. Well, the way that Java manages memory and bounds checking, it's more automatic, and it doesn't allow for as much of that. So a buffer overflow exploit in Java it's almost unheard of. And these features also make Java programs immune to stack smashing. So stack smashing is when you're exploiting certain aspects of the TCP stack. So you're essentially spoofing protocols within the stack in a way that the stack doesn't normally facilitate. These types of attacks have been described as the single most pernicious problem in computer security today. Buffer overflow is still really the scary one, because if you can buffer overflow an application, whether it's a web application or not, chances 9 times out of 10 you end up with a command prompt at the privileges that the application is running at, and the application is running at root or administrative access. All of a sudden you're booted out of this buffer overflow into a command prompt with root level access. So the explicit static typing of Java makes code easy to understand. The dynamic checks ensure unexpected conditions result in predictable behavior. How many of you hate Java? It's funny because I know a lot of Java programmers that really don't like Java very much. I like Java, but you know, it's a lot more complex to code in Java than it is in, say, if you're just writing a script, comparing Java to, say, Python or PHP. You know, and but I like Java, and I like the security features that are in it. What Java can't do is it cannot defend against implementation bugs that occur in trusted code. And what do these bugs look like? Largely, they look like a failure to validate input and a failure to validate processes. If you're developing trusted code in Java, Java doesn't have a way to ensure that your input validation is up to where it needs to be. That falls on the programmer. Such bugs can inadvertently open the very holes that the security architecture was designed to contain, including access to files, printers, webcams, on and on. And in severe cases, local programs may be executed or Java security disabled altogether, and lots of other scary and bad stuff. So, input is often not validated for any one of the following reasons. it might not be recognized as input. The source of the input is considered trusted. So because it's coming from a trusted source, it's not validated. The implicit assumption that someone else has already performed the validation, that goes back to that trusted relationship. Performance is more important than security. That's actually a big one. Insufficient time, not validating input is a high security risk. And frankly, it's the single highest risk in Java coding, in Java development. Input validation is probably represents 90% of the coding security issues in Java.
What do you say input validation? Let's say you have control which data goes. What kind of validation do you do?
So give me that example again, I didn't catch that.
If you have text field which enter data goes,
Okay, date of birth.
what kind of validation do you use?
Well, I certainly don't want to have a, get, put, I don't want to allow an escape character.
So
on
do you
that.
need to check is a date field or not? If it's date field, you pass validation or?
Well, if, maybe I'm only allowing numerical,
It's date field, it cannot be numeric.
well, it can. It could be 01/05/2013
It's date.
in the date.
So it's not date format, it's only validation of programming terms, it's validate is a date format or not.
So I think, I'm not sure that I understand what you're asking, but I think the point is that, for an example, if I wanted to try and inject some code at that point, I would try and inject a statement behind an escape character. So I shouldn't allow an escape character to be, if somebody puts an escape character in that date of birth field, I should have something that recognizes, hey, there's an escape character in this field, I don't allow that, and then it comes up with a little error box that says, sorry, try again.
It's you declare that as a date field, you cannot enter escape characters. It's will be child error, it's not date.
Because you've typed it as a date field. Well, yeah, I don't know how closely Java is going to enforce something like an escape character. I don't know. I don't know the answer to that. And it may even depend on what version of Java you're developing in. I know that earlier versions of Java, even though you designated a certain type of data, it didn't enforce it explicitly. So you could sometimes enter, if it was looking for numbers, you could sometimes enter an alpha character or an escape character or something else, and it wouldn't just see that and error code that out. That actually is more common in other programming platforms. Java actually does a better job of that. I just don't know if it's really foolproof. So here's another one that is pretty important. Design and write code that does not require clever logic. I think the idea is we want to be creative, but we don't want to be clever. And there's another good reason for not coming up with these really intricate, weird lines of code, and that is that anyone plan on working for the state for the next 100 years? I don't. And when I leave, somebody's going to have to come in behind me and try and figure out everything that I was doing. And the same is true of you. When you leave, somebody's going to have to come in behind you, pick up your code, and try and figure out what you were doing. So we want to make it, you know, something that is pretty standard. APIs, this is an area in Java where there's a fairly significant security issue. And again, it's all about the security. I mean, Java has built-in security around APIs, but if it's a trusted relationship or trusted code, the security aspects of Java are not going to be enforced in a way that's really going to eliminate that security risk. So again, it falls on the programmer to make sure that that input, those processes are validated. And avoid duplication. Duplication of code and data causes a lot of problems, security and non-security. Both code and data tend not to be treated consistently when duplicated. And if you've been doing this for any length of time, you know all about that. And you'll know all about this. The privilege restriction, the principle of least privilege. Again, if you develop a Java application and you're running that at administrative or root access with that level of privileges, and somebody can take over that application, they now have the same privileges. There are very few good reasons to run any application at administrative or root level privileges. From a security perspective, that is certainly true. For applets, the best approach is often to leave the jar files unassigned. The application then runs in a sandbox, will not be able to execute any potentially dangerous code. It can execute it within the sandbox, but it doesn't get out. The application will be safe for the user to run because if it attempts to execute security-sensitive code, the JRA will throw a security exception. This is one of the things that makes Java, in my opinion, a lot more secure than, say, C or C++. Establish trust boundaries. But again, even though you've established these trust boundaries, you still need to go back in and validate. Trust but verify. Sorry, I'm going through these kind of fast. I talked too long in the front end, and now I've got to bring it through the back end. So when auditing trust boundaries, there are some questions that should be kept in mind. Are the code and data used sufficiently trusted? What are the terms of that trust? Could a library be replaced with malicious implementation? Just because you've got some code out there, can somebody go out and replace that with something malicious? Is untrusted configuration data being used? Third party. Is code calling with lower privileges adequately protected against? And minimizing the number of permission checks, another thing that is important to maintain the security benefits of Java, and encapsulate. So this is back to that sandboxing, encapsulating objects and code and processes really makes it a lot more difficult for an attacker to exploit any security vulnerabilities that may exist within Java itself or even within your custom code. And then, of course, there is the issue of safeguarding your code. If you're writing the JavaScript and you've got it either embedded in the HTML or you've got it sitting on a directory on that site that somebody can actually gain access to your code, pull it down, and replace your code with their own similarly named JavaScript, you know, anything can happen. So on a website, it's particularly important that we safeguard those directories and we don't allow that directory traversal to occur. And then commenting. This is something that I would encourage you to do in your code. If you should have the code that you're going to push into production that is potentially going to be exposed, and then you've got the code, your working code. And in your working code, you should have good commenting in your working code. But if you're creating an applet or a JavaScript that is going to potentially be exposed on the internet, you want to take all of those comments out, because if someone gets a hold of that, you're just helping them figure out what you were doing, and it just gives them a shorter path to understanding your code. Consolidating all JavaScript files to a single directory. You don't want to have these files scattered all over. It's really difficult to secure them if they're in multiple places. And that is all the time we have, and that's all I have. Are there any questions or comments?
Do you have any recommendation for tools that we can scan our web application?
If you go to that lowWASP site that I referred to earlier, you'll find they have a whole collection of tools that are really good. A good open source web tool is Burp Suite. Burp Suite has an open source free version, and then it has a paid version. The open source version is pretty good, and gosh, there are just almost too many to go over. But even something as simple as Nmap. So Nmap has a scripting capability. You can actually write your own scripts in Lua, but it has a huge scripting library, and a lot of those scripts are also very effective for the kinds of attacks that we've talked about today, or at least seeing if those exist. Any other questions, comments? Don't make your questions too hard, because I haven't had my donut yet, and my brain's not working at full capacity. I have to think longer. Okay, well, thank you.